Right, good afternoon. I'm Seneviratne, and I'm supposed to cover whatever the phase after implementation, mainly testing. Now, why can you all hear me talking, or do I have to use a microphone? Right. I don't know if it will be too much of it. Right, why I selected this one? Because as an examiner, in the past I observed one of the weakest sections we see of a student happen to be this testing. Why? Informally, what I can conclude is you start working on your project, and day before the presentation you finish your task, no time for testing, hope for the best, pray to the gods, and come for the presentation. Oh, why you are, right? When as examiners, when we ask, is your system working? Yes, perfectly. God bless me. And when we start the presentation, you get into trouble, here and there, sometimes, some screen blanks or unable to connect to your database, things like that. Why? Because of poor testing. Let's see how we can help you to, overcome these issues this time. But remember, first of all, I'm not targeting a particular development methodology or anything, but testing and also whatever the evaluation in general. So, what am I supposed to do under testing? Right? You go through most of the previous destinations. The testing part is sort of either common or too vague or sometimes totally irrelevant to the project. Why? So there are two terms always go with this testing. One is called verification and the other one is called validation. So in simple terms, under verification, what we are trying to, as developers, what we are trying to do is, are the algorithms coded correctly? And validation, does it meet user requirements? Right? So I'm not supposed to cover a software engineering course here. Therefore, if you want to find more, then you have to go and refer to Ian Somerville's book on software engineering. It's available on the internet in the 9th edition. You can download it and read. But for the time being, remember two things. Or the algorithms, whatever the algorithms we develop, we have coded it correctly, no bugs, no crashes, right? Unknown variables, unknown unavailable function, things like that. Or the other thing is, okay, I have developed a system as a partial fulfillment of my project, but will it satisfy my users? But anyway, sometimes, most of you bring a letter saying that, so and so developed a system for my ABC company, and it's up to our expectations, and this letter is issued on the request of the student, right? But that does not help you to satisfy the project examination board, unfortunately. So make sure that you achieve those two. So what is testing? Is an activity whose goal is to determine if the implementation is correct. Right? So you have developed the system. From this testing process, you need to make sure that the implementation is correct. So sometimes students ask, did you test it? Yes, it's working perfectly. So we need this project examination board, proofs, right? You have to provide, evidence of testing. See, this is working perfectly, right? But what are we expecting? Some sort of documentation in your dissertation, right? As Mr. Harsha Vijayawardena mentioned, there are so many automated testing tools to grow with various frameworks. So you must have used it, right, without knowing the purpose. So what all you have to do is, whatever you do in this project, make sure to document it where appropriate, right? In the testing section, in this testing chapter, make sure you have whatever the methods you follow, whatever the strategies you use, be properly documented. Testing, sometimes the examiners look for your test plans, right? Whether you have properly tested your system. So testing involves some activities, testing activities. So first of all, you need to determine what your test activities are. So depending on the activity, you have to select appropriate test data, right? And one advice, don't wait till the last moment to address these testing issues, right? Don't develop your system and then start a formal testing session. It will never take you to any fruitful output, right? So you have to start while coding your whatever classes or functions or procedures or modules or whatever, right? Then and there we have to determine, okay, how can I test this later on? Determine the test data, appropriate test activities. Thereafter, select appropriate test data to do that particular activity, and with the same test data, you have to manually or with the help of a computer determine the expected results. If I use this test data with assuming correct situation, I am expecting whatever the expected results as the output. Then you conduct the test, okay, run that activity and with the test data and collect whatever the outcome, right, as your test results. And finally, compare the test results with predefined expected results, right? So that either there won't be any errors, or if there are any errors, you can go back and debug. So that's simply the test procedure. So designing of test activities, you can't don't do any arbitrary testing, right? Sometimes what we see is you have a system, it has a login screen. You say enter valid username and a valid password. The system accepts the user. Enter an invalid username and an invalid password, then reject. As examiners, we know you have done it just for survival, not for a genuine test purpose. Why? Because testing is not a very simple thing. You have to go back to your requirements or software specifications and then study it and work out, okay, what type of data is allowed. Are there any boundary conditions, limits? In that case, you have to see what happens if you enter data within the boundary, within the limits, or what happens just beyond the boundary. And then you have to come up with correct error messages and see whether the error messages are triggered, or otherwise whether the system stops or whether the system crashes, things like that. So because of that, you have to design your test cases, test activities. So in order to design your test activities, remember you have to go back to your functional specifications of the system. How the system will be used, that is also important, right? Sometimes you develop a system with say user interfaces all in English, and now this is going to be a big project, therefore you will be the developer, you will be the designer, you will be the user, and you will be also be the demonstrator and defender as well, right? But the examiners will go beyond that and say, okay, you have been developed this to be used in rural areas where you don't have people with English language proficiency, right? Will this create problems because of the user's background? So because of that, remember, not only functional specifications but also how the system will be used has to be taken into consideration, right? So with that, what you will perform is informal terms we call black box testing. So we have a system what we have already developed, and you see whether this particular system works according to your specifications. Externally, we don't bother to see whether it has been developed using object-oriented fashion or structured fashion or whatever. So black box testing, remember, it ignores the internal structure, right? Whether you have developed it in functional approach or object-oriented approach. Test activities will be based on expected external behavior of the system. This is just one approach, right? This will not be the final solution to your testing phase. So this is one, right? So you take the entire system as a black box, don't touch inside, and see whether this system is capable of producing expected results and behaviors. So what a test case? Now remember, as I told you, right, you have to document all your test strategies, test cases, test plans, etc. right, in the dissertation, right, as evidence. So test cases are defined by a statement of test objectives. What's the purpose of this particular test case, right? And test data set, the one you predefine, and the worked out result, the correct expected result. And you can't, as most of the big students do, not only big students, most of the students do, don't wait till the last moment. That must be carried out concurrently with the system development. During the implementation, while coding, then and there you have to pick things later on to be tested, right? Sometimes, remember, you may have to refine test cases during implementation, but my experience is most of you, while documenting or while writing the thesis, when it comes to testing chapter, then you somehow create some test cases and document it, right? What all you are worried about is getting some screen prints, that's all. Don't do that. That's why you get into trouble from the PEB. Right? So high level generic test process, you may not agree with it, but at least you must have this. You have test planning and preparation, carrying out test, see whether the goal of the test or the objective of the test is met, or then analysis of the test result and follow up. So you do it, and and if you do it during the project period, not just before the presentation, you will succeed definitely. Right. Anyway, those slides will be on the LMS later on, so you don't have to copy that, but just try to get the idea. So what are we looking for? This test plan is a document describing the test cases. Right. Don't fill your main chapters with all the test cases, have them in the appendix, but a summary must be written in the testing chapter. Highlighting the important things you did. If you use the software tool to test it, document it properly, and the things you tested, your strategies, your test cases, and things like that, document in one of the appendix sections. Test planning and preparation, testing objectives and targets in terms of reliability, performance, customer satisfaction, right? How many of you, little while ago someone asked whether you need a client, right? Why now it may not be compulsory, but we insist you to have a client. Why? Because not only you, at least the client has to test the system. And before issuing that acceptance letter, the client has to say, okay, I agree with the thing and I am happy with it, or genuinely say, the system is there, fully functional, but unfortunately, it does not meet my requirements. Because user satisfaction is important. You have been learning it in systems analysis and design as well. Then test strategies, right? Not just to pass the exam, but things like that. I have listed some things. For example, the last one before the last, people and the skills. The system must be used, must be tested not by the developer, because when the developer, like you as a student, try to test it, it will be biased. Right? Let someone else, a friend of yours, or your supervisor, or a client, or somebody working for the company to test it, right? And also schedule, when to test it, right? Sometimes you test component by component, or you develop a test bed and try to test the classes, etc. But it depends. There are test risk and contingencies is common, so far we observe it as a common problem because of poor project management. Why? You don't leave enough time for testing, right? You are in a rush, you just finish your project day before the presentation and come for the Viva, and the examiners test you and ask you to come back with the same project next year and the following year with a new project, right? That's the result of the testing. Don't get into that situation. The main reason is lack of time. So from the very beginning, plan your test cases, right? And make sure that your system is perfectly working, and then and there you introduce your test cases. And don't end up having half-done projects. That's why your testing not going to be a complete process. And I have given here sample entry, right? But you find it in most of the literature and on the web as well. You can use it, but remember, when you have too many things in the big project, too many items recorded for each entry, you will need another 50-60 pages in the appendix to present all the cases. So my advice is, do it for your reference, bring it for the presentation to prove that you did those things, but do a write-up in the dissertation on the testing chapter, and have selected the entries in the appendix, but have this fully documented one for your reference. Yes. Sometimes what happens is you say you tested it, but the examiners say no, you haven't done it. Where this where do you draw the line and say because I have done enough testing. So one point is the coverage. You have to define. Okay, this is where I need to draw the line and say these are the things to be covered. Because if this is a project, finally a project, you have a time, limited time. Therefore, you mainly concentrate on the important areas, important scenarios than very minute ones. So functional testing and structural testing, white box and black box. One is treating the entire thing as a single entity without touching the internals, and the other one is sometimes refining the internals as well. So documentations involve project test plan, component test plan, integration test plan, use case test plan, system test plan. You must have done under software engineering and systems analysis and design. So you have to go through and refer it. I think I have a diagram showing the relationship, right? And depending on whether you have developed it in structural way or functional way or object-oriented way, you have to use different plans. And you have to again identify the features not tested, because the examiners are usually good at finding faults with your system. Therefore, you must really identify the features you not tested, right? And also regarding things you borrow from the internet or other resources, reuse components developed by other people. That's why we say, declare it at the very beginning, saying that I used this particular component from the internet. Therefore, I am not responsible for the internals of that, right? So if there are errors caused by that, you have to somehow negotiate with it. Test suspension criteria, and sometimes when when the testing goes out of control, you have to sort of do it up to a particular level and then forget about it and declare it, or in the dissertation saying that I tested it up this level. Why? Because it's more than enough for me to do. And also contingency plans. Okay, sometimes you report an error and then ask the user, okay, this exception error occurred, so you have to restart the system because I can't avoid it. Component test plan purpose is to define an overall strategy and specific test case used to test a certain component. Sometimes in object-oriented ones, sometimes you may be interested in this. And unfortunately, you have to have one for each significant component. So if there are 100, you will have another thesis covering the thing. Component sections, objectives for the class, guided inspection requirements, building and retaining test suits, functional test cases, structural test cases, all these things. And finally, when you have a class, integration testing again is important, because classes are sort of separate things. You link with interfaces. Therefore, when you are integrating it to other components, you have to do proper integration testing. And use case test plans. So high level end-to-end system functions of use cases. So things you have to worry about. So why? At the very beginning I said, you have to have a chapter called testing, and have your sample test cases in the appendix, but for as a proof, have all the documentation with you in case the project examination would get any doubts. So let me skip some of these things. You can system test plan. Yes, coverage indicates which items have been touched by test cases. Some has code coverage, post condition coverage, model element coverage, etc. So that is where you clearly say, okay, these are the things I did, and why? Because I felt it's sufficient, and because of the time constraints, I limited this to this level, right? So what we want is, whether you have done it formally and whether it's adequate, right? So you have to argue, because the defense is for you to defend your decisions, right? So why? I mean, with testing, as I mentioned, we are making sure that our system works, and things which go wrong. Wrong requirements, missing requirements, requirement impossible to implement. That is what usually happens. You promise to deliver something, but unfortunately unable to develop it correctly, and you come with half-done system and tend to get a poor trading. So that is also possible, and fault design, fault code, faulty code, and improperly implemented design. So those are the things usually happen. So that's why we need testing to make sure that those things do not appear in your system. I have further when you are testing, we can't expect you to do an exhaustive testing, right? That's why I said, you have to discuss that with your supervisor and draw a line and say, okay, this is more than enough for the project, right? So for that decision, you need your help of your supervisor. Then when it comes to evaluation, purpose of the evaluation, the measurement of results or the output or whatever in the solution against established objectives. So in the morning, I saw when you have been asked to concentrate on your introduction, there you mention names and objectives. Sometimes you say, I want one of the objectives is to come up with a highly user-friendly package, right? Then that term highly user-friendly package you will have to quantify and or justify at the end. Right. So what you have to do is remember when you declare things in your introduction in to vague form or informal terms, you may get into trouble in the evaluation phase of the dissertation or the project, right? Therefore, you have to, during evaluation, you have to revisit your first chapter and get the list of objectives you mentioned there and see, okay, I promised to deliver that or those things, but okay, yes, I delivered it here, or things I delivered, managed to deliver, and things I couldn't deliver due to reasons. Before any system can be properly evaluated, it's important to have a clearly established set of measurable objectives. So when you are writing an introductory or introduction chapter, make sure to list your objectives in a sort of measurable or justifiable way. Right? Don't use terms like highly user friendly, and you will have to prove it for the project examination board. Right. So again, the advice is don't wait until the end to determine how it will be evaluated. So you finish your introductory chapter 6 months prior to final submission or whatever, and sometimes if you don't do at the beginning correctly, you may get into trouble. So starts in the planning stage, you break down the problem into measurable goals and objectives. Then after implementing the program, you measure the results against goal. For example, I picked this one, a highly user-friendly system, but it's like a pretty lady. It may be the lady may be pretty to you, but not to others. right? So don't use terms like highly user-friendly system because definitely you will be having a very hard time at the Viva. But most of you forget things you can use in systems analysis and design. I think you must have done facts gathering techniques. Why not use surveys, questionnaires, prepare a questionnaire and give it to users with 5-6 options. My system is the interface of the system is highly user friendly, not so user friendly, bad, acceptable, or finally weak or very weak or something like that, and then analyze those and present it. Right? You can interview people and record their comments. And you can do, if the system is being used, you can go and have, you can observe it and record the information. Some common mistakes you find at the Viva, and sometimes people develop standalone systems, standalone development on a laptop or a PC, and they claim it's network or web enabled, where their database is Microsoft Access, right? So think about it. Why? Because it's an evidence of you have not tested it and you have not evaluated it properly. Right? Then single user system but claims it's a multi-user. Why? There is no login name, no password. You just use it in a multi-user environment. You need to authenticate the users, see who did what. So again, problem. So sometimes MS-based development, Microsoft-based development, but claims platform independent. Okay, so if the examiner say, okay, I have a Linux system here, you just implement it. Doesn't work. Why? In Microsoft, most of the things are case insensitive, right? But when it comes to Linux, it's case sensitive, right? So don't claim without testing. And the interesting thing is, you have your IP address set to, this one magic number 127001, right? And it was on your browser. Okay, you install it on one of our machines and show, use your machine to demonstrate it, or you use your machine connect it to our network and demonstrate it using a browser running on one of the other workstations. You type the same IP address 127001. Server not there. Why? Those who do networking knows what. Right? It loops back to your machine, whatever the host. Right? Not to whatever valid IP. Right? So those are some testing. Right? Lack of testing. Right? Before you claim, make sure that you test it. And browser compatibility. Sometimes your systems work on Internet Explorer, and sometimes you say because now I am using Firefox and it's giving problems. And these days we have standard and wide screen displays with different resolutions, right? Again, make sure that you clearly identify, okay, my system works only with these resolutions and these displays. And most of you never bother to think about taking backups, backing up your important system data, and in case of sort of a system crash or system failure, how to recover from or reinstall from the backup, right? And for testing, you can, if possible, why don't you try parallel run? If they are already doing it manually, a payroll or stock control or library management, do it parallelly on your system so that you may be able to compare the documents and say, okay, the system works perfectly. Run with historical data, you borrow last month's data and see whether you generate the same, the system generates the same payroll or whatever result. Or sometimes use handmade data. And sometimes human-computer interaction issues, HCI issues, right? You develop, with small letters. These days you have high-resolution laptops, so you have a screen full of information with smaller letters, but unfortunately the older people can't see it. You are providing very hard time to them. So think about it. So again, as a as a result of not having user testing. Installation dependencies, sometimes you bring the system and say it works, but when I try to install it here, it doesn't work because IP addresses different, DNS different, gateways different, I don't know how to set it, or the version slightly different. You have to, so ultimately you find, it works only on my home computer, nowhere else. Why? Not because of anything wrong, but poor testing. Right. That ends my presentation, questions and answers. See you later.
Questions?
Yes, now the question is, are you allowing to use open source testing tools? Our objective is, if you have documented it properly and if the project or examination board is happy with the evidence you provide, yes. But you need to convince the project examination board. Do it whatever, as Mr. Harsha said, one API, but make sure that you convince the PEB that you have done 300 hours of work within 1 year, not in 10 years, after so many repeats, right, in 1 year, right? Because there are students who repeat for 7 times. We are not taking cumulative experience. So yes, you can use tools, but document it properly. Okay, I tested it. These are the things I did, and yes. Integration testing and interface testing. Harsha, you want to comment on that? Because in object-oriented, you emphasized on object-oriented, you want to explain integration and interface. Integration testing and interfacing.
Integration is when you integrate with your components.
Sorry.
Yeah. I will answer this. There is another interesting one you asked earlier about if you have testing or integration testing, there are certain, when you start integrating, there are different components, different modules together, then you have to make sure that they work properly. So that is the integration. And also integrating with all of this together. Now let's say you have when you want to integrate with your database management system, right? And with let's say you are with your modules, then you have to test and see that they actually work together. The problem, whatever the output that comes up. So, but then modules also, different modules like your APIs, for instance. Right now, you are giving the party. When you try to integrate, there are also that it has to make sure that they will actually function well. But the interface testing is what I understand. The interface testing is an interfaces, right? But that you can do very good unit testing. You have tools also. Now, for example, Eclipse, you can define it and put it there. Then you can basically do an interface that you test it with the boundaries. And you get the whole thing, you can test it out through these tools. But you can also do now, when I normally do is when you develop the interface. In fact, Mr. Abdul Hassan and I were talking about this. Normally, at the time of design journey of your applications, or when you start doing the SQL, even main SQL diagrams also, I can come up with a test cases. Because I know exactly what the output would be. So with that, we can, with that also that using some of these tools, we can test it out. Is that okay?
Yeah. Whoever asked the question.
Yeah. Yeah.
Let's say I build a system, this platform depends, and
I can't hear you.
let's say I build a system, this platform depends, and with a machine code, you can make it platform independent.
Platform dependent, platform independent.
Yes. Then if I submit a platform dependent system with a one screen data,
Wait, what?
then let's say a small system. That's I indicated as platform dependent.
Yes.
And it's platform dependent.
Yes.
You all know that within another little code you can be platform independent.
Yes.
With a one screen data.
Point scheme.
Yes.
Obviously, there will be a difference because, original dependent one, suppose the effort is X and this little delta X is needed to make it platform independent. Therefore, you get better, grading with platform independent version. Definitely.
I think better to have a platform independence is a lot of people don't go for Java sometimes because of the platform independence. Now, I also very much think because the different devices, different operating systems, platform is independent. Now, Microsoft, because of certain reasons, right, because of their marketing strategies, they don't like to have a platform independence. But right now, if you look at the Visual Studio, if you look at the .NET frameworks that have come out, you can see that they are trying to move into platform independence. Right now, you know that C# can be whatever that is, what we call mono. Right? Mono is there right now. Mono, you can have it on Linux systems. Right? So it's a platform independence that they are trying to go for. But it has not taken up that much. But it's better to have platform independence if you like. But I would now, if you are doing a Microsoft purpose, obviously for Microsoft, right? Unless if you say C#, I can run it on Mono and different other .NET frameworks.
Furthermore,
Yeah.
in my specification, the system must run on this specification. Let's say my system runs on about 100 GB of hard disk. Then, let's say, you say you need a VGA fighter or something.
Yes. That's your minimum requirement.
Yeah, minimum requirement.
Yes.
And when you are taking better version to consider.
I don't think so, right? I don't think that's your thing. But the only thing is that when you come for the presentation, make sure that you have your minimum requirements. Normally what will happen is you will request for let's say that you can't bring your machine or something. You will say that I don't will be allowed now. You will bring, right? So otherwise, but there are certain things I remember in the past, they were asking that we need this, but I don't know if we allow them. Yeah, we want to ask you the course.
Yes, let me add something to that section. Basically, when we look at based on the objective and the scope, we don't worry much about the technology used or whether it's platform dependent or not. I think those are various features that will come up. So, if the original objective is met, we may not emphasize on these various issues what was raised. So, don't take those as like core issues. Basically, depending on the problem, depending on the solution type required. Now, for example, if that solution has to run on various platforms to make it usable, then it is a requirement. But if it is used by the particular environment, then the platform independence is not the issue. So, depends on the problem and who are the users, for what purpose they are using, and the requirements from that.
Yeah, there is one question. Should the system be compatible with each and every browser? Like, as Fabiana said, if your requirements does not do not demand the system to be on all these old say Internet Explorer 2 or 3, don't worry about it. Right? Try to satisfy the requirements and objectives.
So, for example, if you don't have time to bring your software and install in our machine, you bring a machine which you have already developed and tested. So, and same for browser. You bring a browser, you show it in that. We won't ask to run it on a different browser. We will be happy with the browser you are using, provided that provides a typical user's requirement. So, it may have shortcomings, not compatible with certain things. Those are minor things. Those can be identified and explained in your evaluation thing. Those can be user improvements as part of the project. Objectives are basically somewhere it is meeting the requirement. Then that is what we want. And we won't be looking for these different